this video is on just general properties of aqueous solutions. So first we need to define solution. So a solution is a homogeneous mixture of two or more substances. So recall that the prefix homo means same. So homogeneous, made of things that all look the same. So the whole thing looks the same throughout. You're not going to have different layers or pieces or colors or parts you can see. So it's got to be two or more. Lots of times it is more than two. The common misconception is that solutions have to be liquids. They do not. And I'll give you some examples of things that aren't. So I'm going to write doesn't have to be a liquid. All right, so solutions are made of two parts. So they're made of a solvent and a solute. The solvent is the component that is present in the greater quantity. So if you have two parts or multiple parts, whatever you have the most of is your solvent. Now, water is considered the universal solvent because that dissolves most things. And for most cases, when we are talking about different solutions that we may come across in the chemistry world, many of them are going to have water as the solvent. The solute is what gets dissolved in the solvent. And sometimes this is very obvious. Water, salt gets dissolved in the water. So salt would be the solute, the solvent would be water. Sometimes it is not as obvious as that. Like let's say you have two liquids. So another way to think about this is your solute is going to be whatever you have less of. If your solvent is greater, your solute is less. And it can be sometimes confusing to think about these two different words. They both start with S. They might seem similar at times. So one way to remember it is the smaller quantity is also the word with the fewer letters. All right, so aqueous solution. So instead of just saying solution, we can specifically say aqueous solution. These are solutions in which the dissolving medium is water. And we label them, and you've already been doing this, and you will more coming up. We label them with AQ for aqueous. So you'll see that a lot when we write our solutions. So just to give you a little diagram, let's say I have a solution in my beaker here, and maybe I have all of these. I'm going to use these to represent my water molecules. Now let's say I add some sugar to this water. So these are my sugar molecules. Now the question I would pose to you is, what's my solvent? My solvent's going to be what I have more of. So if I look at how many H2O molecules, I have more of those than I have sugar molecules. So this is my solvent, which would make my sugar molecule my solute. And together, they are a solution. Now you'll sometimes see me abbreviate solution, SOLN, or sometimes I'll put an apostrophe in there, but just so you know my shorthand. All right, so with solutions, you can have more or less solute. When you have more, we typically call those a concentrated solution. So that's when you're going to have more solute dissolved. Versus when you have less solute, we call that a dilute solution. So you'll hear these two terms, and we'll talk about making things more dilute or more concentrated, and we'll kind of discuss how to do that. So some more examples. Oops, sorry. If we make a little kind of chart. So solute plus solvent equals your solution. So to give us some examples, let's say I'm looking at the solution of air. So this is a gas, that's a solution. So what's our solute, what's our solvent? Well, whatever gas is the most abundant, the greatest quantity, that's going to be our solvent. And in our air that we're breathing in, that is nitrogen. And now there's actually quite a few solutes. It's any other type of gas or particle in the air. So I'm going to write all other gases. So this would be like O2, thankfully. This would be our CO2. Hopefully not things like carbon monoxide, CO, things like that. But any other gas is in a smaller amount than nitrogen. So anything else is a solute. So let's draw a line here. Another example of a solution that's not a liquid would be something like 14 karat gold. Now, anytime metals are mixed like this, that's called an alloy. So things like bronze or steel, and there's different types, those are all alloys. Now, for 14 karat gold, the solvent, the thing you have the most of, is gold. But the reason they'll use 14 karat gold in jewelry sometimes instead of pure gold, they'll add these other solutes in to make it stronger, to give it different properties. Same with like steel and bronze and things like that. So the other things that are mixed with the gold in 14 karat gold are things like zinc, nickel, there's usually some silver and some copper, and those are all your solutes that you have in lesser quantities. All right, one last piece with this. Not everything will dissolve in everything else. Like just because you add a solute to a solvent doesn't mean it will dissolve. So a common phrase that you'll hear is like dissolves like. And what this means is polar compounds will dissolve other polar compounds. And then on the flip side, nonpolar compounds dissolve nonpolar compounds. So water, if you remember, has a structure like this with that bent shape, which makes it a polar molecule. Oil is nonpolar, and this is why water and oil do not mix. They will not dissolve in each other. So maybe you've had this situation in art class with paints. Some paints are water-based, some paints are oil-based, and you have to use the right solvent to get them to dissolve when you're trying to, let's say, clean your brushes. So those are aqueous solutions, kind of just the basics.